Hello, hello. Welcome to another edition of Live Code Tuesdays. My name is Sohan. I'm joined by Thorsten. And yeah, hope you had a good longish weekend. At least most part of the world, there was a Easter break. And yeah, welcome to the stream. So first things first, Thorsten, our channel hit more than 1,000 subscribers.
Yay!
Finally, it was a long and arduous road to 1,000 subscribers, but hopefully that we accelerate that growth soon, and maybe with your help we can. I see Kai in the audience. Hey, Kai. Kai joined us last week for a great stream on how Zeiss uses WebAssembly in enterprise. If you haven't seen that one, check it on our YouTube channel. Our good friend Bunny is here as well. Nice to see you after a while, Bunny.
Hi,
I was not
Bunny.
on stream last week, so missed you. Yeah, so today we are going to talk about real-world examples of the component model. And this is coming from a demo that Thorsten did at this conference called WASM.io in Barcelona a couple of weeks ago. And he did something very interesting during the conference as well. Thorsten, will you tell us what you did in the conference with the hats and stuff? I thought that was super interesting. And before that, I'll just say a quick hi to Vamshi and Dean from Rio. Hey, Dean, nice that you're joining from Rio de Janeiro. Always wanted to visit, maybe one day. Yes, Thorsten, tell us what you spoke about in the conference.
Yeah, first of all, hello everybody. Thanks for tuning in. Also from my side. Yeah, so as Sohan already introduced, I did a talk at WASM.io, I think it's 2 or 3 weeks ago, right? When I demonstrated what one could build with the WebAssembly component model as of today. And one of the key values that the component model provides to us as developers is the possibility to mix and match components written in different languages without, taking care or having to care that much about how data is laid out in memory. And to, emphasize that me switching from one language to another, I had like several hats in matching the colors of the programming languages. So there was an orange red for Rust, there was a blue hat for Python, and a green hat for Node.js. So yeah, I managed it to basically, I think, swap the hats like 8 times or so, messed up my hair, but hopefully kept the audience entertained and had them to follow along with me, switching context that quickly.
Nice. I thought we could maybe even do that today. I'm wearing my hat at least. So,
Aye.
Yeah.
Yeah, there was already a question on Twitter if I'm doing the hat thing again, but unfortunately, as when I came back home from Barcelona, so the youngest my youngest daughter grabbed the hats, and they are like gone, at least for me. Yeah, so no hats during this iteration.
Yeah. Ah, well, that's okay. But because what Thorsten's going to show us is a very real life sort of use case of getting started with the component model. Now, we did a live stream with Ryan about the ins and outs of the component model. So I highly suggest that you check that out. It's on our YouTube channel. He goes deep into how the component model works under the hood. Like really get down to the details. So you should check that out. Dean has a question about the component model. Dean, we'll get to that in a bit, right? I think once we start talking about it, I think we'll get to this use case in a while. And yeah, Thorsten, I agree with Bunny. I think it's a really cool idea for keeping the viewers awareness of what you're doing, especially in a newer topic. So definitely going to steal that for a future talk. So
Yeah, so basically, I think before we dive into the samples, I can easily, give you a quick recap of what a component model is and what one could expect from actually adopting it. So basically, you can think of the component model, the WebAssembly component model, as an addition to core WebAssembly. So there's still obviously WebAssembly, but there are some shortcomings when it comes to using WebAssembly modules from within other modules, or composing bigger, systems from multiple of those modules. And one of the biggest pain points is that WebAssembly has a very small type system by default, right? We just have like integers and floating point numbers, and this makes it hard to specify rich APIs, for example, right? However, we could just use those primitive types that WebAssembly offers and reuse them to, for example, say, hey, actually, this WebAssembly module wants or receives a string, and the string is somewhere stored in heap or in a shared memory buffer, right? And then we can use those primitives to say, okay, you can find the actual string at this address, and or provide a pointer to the address of the string in the memory. However, there's still one one thing that's very difficult, that is obviously different programming languages lay out data structures differently in that particular memory. So we as consumers must be aware of how or which language is used to build that WebAssembly module, and how does that language lay out, for example, a string in memory. And this is obviously something that you don't want to care about that when you try to build line of business applications or enterprise applications, right? So this is where the component model comes into play, because it defines something that's called a canonical ABI, which is a mouthful, right? So a canonical application binary interface, which is basically unifying and standardizing the way how data is stored or how data is transferred between those components, so that for example, let me impersonate into a Node.js developer. I don't have to know how Rust lays out strings in memory, right? And this makes it easier, obviously, to interact with, let's say, foreign or components written in different languages. And on top, we can use a richer type system as we could use it with pure WebAssembly or core WebAssembly modules. So having a rich type system allows us to specify greater or higher level APIs. And instead of having the consumer of my components to look into my Git repository and try to read through the public API documentation that I hopefully published on GitHub as well, there is WebAssembly interface type, which is basically interface definition or description language that we can use to describe the intent, or what is that particular component providing, or what does it rely on. So maybe you've used gRPC in the past, right? They have Proto as an interface or as an IDL. So it's fairly similar, right? We can write high-level contracts that are that outline what our component provides. And those two values, the canonical ABI and having rich interfaces defined in WIT, makes it super easy to compose bigger applications from multiple components, no matter which language was used to write that particular component, or I think, now I lost my thread.
Yeah, I mean, yeah, you're talking about like the canonical ABI and the what gRPC uses and protobufs. And incidentally, Bunny also mentioned that the WASM component model needs code support for protobufs. So you sort of preempted that question, I think, already. But yeah, so that was pretty cool.
Okay, I think I can easily bring up my screen.
There you go.
You did so? Oh, great. Let me open up this one. So I think it's easy to visualize what the component model offers. So let me start now. Okay, swap the displays. So now, Swan, can you give me a quick feedback? Do you see my
Yes.
screen? Yes.
Yeah.
Okay, cool. So I think it's easier to grasp what the WebAssembly component model provides if we take a look at, for example, a spin application, right? So the spin runtime is able to execute or to run different spin applications, right? In this particular example, we are looking at an HTTP or an application that reacts to incoming HTTP requests. And the WebAssembly system interface, so WASI, provide or defines an incoming HTTP handler. And the spin runtime is basically looking for or taking a component that provides that capability and runs that, right? So the spin runtime takes care of starting the web server, allocating a port, and reacting or listening to the trigger we specified. And as soon as a request hits that endpoint, then the component is instantiated and executed. So if we take a look at the application developer, right? We build, let's say again, a spin app in Rust, and in that case, upon compilation, we end up with a WebAssembly module that could be. You can think of the WebAssembly module as a WebAssembly component model as a thin wrapper around those core WASM modules. And in the case of a spin HTTP application, that exports the capability to, or that exports the WASI HTTP incoming handler, right? So the spin runtime looks for that. It defines that import, and the spin app acts like a puzzle piece, right, that matches that demand from the runtime. So the app exports an incoming handler. However, we can take this approach one step further and say, hey, I want to use some business logic that maybe a colleague of mine already built and compiled that as a WebAssembly component by specifying, again, an import. And on the flip side, I can use their contract specifications, so their WIT files, together with their WebAssembly component and compose a higher level application from that. And this is basically what allows us to reuse, let's say infrastructure components. So for example, we will look at the sample where we use like HMAC to sign arbitrary bytes, and on the other hand, to verify those. So the business logic is basically exporting the capability to sign data and to verify data, and then spin applications will import those capabilities. And this allows us to, focus on building or solving real requirements, like functional requirements, instead of dealing with the same technical requirements again and again and again. So overall, we are able to become more productive and to build apps even faster. All right, so before we dive into how this looks like in Spin, I have I have some slides, extracted from the original slide deck I've shown at Wasm.io, because it's really important to have proper tooling in place. And the tooling, I categorize it in two different buckets, so to say. So first, we need some tooling to come from our source code to a WebAssembly component. So depending on the language you choose, there are different tools that you can use to compile your source code down to a WebAssembly component. I think in the samples we will look at, we will use all of them on the slide. So, for example, cargo component, it's an extension for the Rust package manager cargo that allows us, for example, to create new components, but also it allows us also to take the Rust source code and compile it down to a WebAssembly Component Model compliant component. On top
Thorsten,
of that,
can I quickly
yeah.
give a shout out to our previous stream? We actually did a stream on the component ISPy project, right? And one of the main drivers behind that project is Joel Dice, the amazing Joel Dice. And we had him on stream. And again, he spoke really about the nuts and bolts of how this actually works. So how, the SDK uses, does the changes like a Python code into like a WebAssembly module. Very, very interesting, especially if you're interested in like, some of the more interpreter compiler side of things. So I put the link in the chat. Check it out. It's a very, very deep technical conversation. A lot of it which went above my head, but if that's the sort of thing that interests you, you should check it out.
All right,
Yeah.
cool. So we have like a set of tools that is language dependent, right? That we need to translate our code into components. On top of that, we need like language agnostic tooling, right? Because at some point we end up with maybe a couple of WebAssembly components, and we have to compose them to become a bigger application. Maybe we have to inspect, hey, what is this component really doing? So Wasm Tools, a project under Bytecode Alliance, that's like it is a CLI, and you can obviously use parts of Wasm Tools in your own project because it's also a library. This is, at least to me, at the current point in time, the most prominent one, the one that I use on a daily basis to compose applications and to inspect what's going on under the covers. On top of that, there's WAC, WebAssembly Composition, and this one is really interesting because it allows you to, describe how the actual composition should look like using a small domain-specific language, and store, the composition itself again in source control so that others can follow along by reading through the declaration instead of just invoking some commands and hoping that we end up with the same state. So WAC is definitely worth checking out. And there is an ongoing discussion if or how WAC should be integrated into Wasm Tools. So link to that one as well in the slide deck. And I think, Sohan, I can upload the slide deck after the webinar or after the live stream, and then we can add that as a comment to the YouTube.
Yeah, on the description or something, so that you can.
That's great. That makes it accessible.
Yeah, and also another quick shout out. So the Bytecode Alliance has sort of authored this book about the component model. If you again want an explanation or want to read about it, the link is there. If you have any feedback about this documentation, make sure you pass it along either to the Bytecode Alliance or to Thorsten and me, because we're also involved in some way in like the setting up of the documentation and improving it, which is an ever evolving sort of process. So do go through it and give us any feedback that you might have about the project itself.
Yeah, this makes me quickly jumping out of PowerPoint and bringing up my browser. So this is basically the WebAssembly Component Model book that Sohan mentioned. So although the link is fairly long, you put it already on there as banner. That's great. So this is more guiding you through the insights and internals of the component model from the point of an application developer, someone who wants to build something with the component model. So this is a great, starting point to jumpstart your WebAssembly component model journey. On top of that, there is the WebAssembly /component model repository, which is which contains design documents and specifications. So that's more if you want to build or lay foundation or build something fundamental on top of the component model. Then you can find all the specs and all the ideas behind it over there. Great. So having that sorted out, I think it's time to move into the demos. So first of all, the first demo is actually to get you going, right? So one particular area or one thing that immediately came into my mind when I stumbled upon the component model is that it is super it's super useful to build like an extensibility story where I don't have to provide like SDKs, APIs, and whatnot for all the popular programming languages. Instead, I can use WIT, the WebAssembly interface types, to describe what third-party components or plugins should be able to do when I load them into an arbitrary host application. So in our in this sample, the host application is written in Rust. You can see Ferris on the right hand side there, and the idea of the host application is basically to accept any input like a string from the user and apply several transformations in a chain, right? So that for example, we will have one that is taking the input and uppercasing it, and there are different things that we could do with strings, right? So to me, the first thing I try to come up with is like the interface. What do I expect from a plugin? And the simplest possible plugin to transform a string is providing is that my host application is looking for components that provide a transform function, right? That can take a string and return again a string. Although in real world scenarios, you would have way more like imports, right? Maybe the plugin must provide its name and a description. Maybe you want like a back channel that the plugins are able to invoke functionality provided by the host application. So that's definitely possible. This is just, try to just provide the simplest possible example. So the host application defines the world of extensibility and says, hey, I can work with WebAssembly components that export a transform function. Okay, so we can obviously use different languages. Me right now picking again Rust and Node.js. Python was also mentioned in the previous slide, so that's also possible, right? And all those components, what they have to do is they have to export that transform function to fulfill the import of the host application. And again, we define, if we take that requirement and write it down in WIT, we would end up with a world of a plugin, and the plugin exports the capability to transform a string and returns again a string. Finally, the host application will then invoke one plugin after another and transform the incoming string by chaining together multiple plugins or WebAssembly components. All right, with that said, I think it's time to jump into VS Code.
Let's do it. Yeah, we have a question that's, I think, in a way, I think there's a tangent from what we're talking about, but it's in a sense it's kind of related actually. Question by Nathan, which is it possible for a WASM guest component to dynamically load and link to multiple child guest modules, or is that only a host capability at this point? I don't know actually. Right? Would you happen to know, Thorsten?
If I understand, so I'm not sure if I understand it correctly, because is it possible from a wasm guest component to dynamically load and link multiple child guest? I see.
But is there, in terms of terminology, is when you're actually building out different components, is there a relation that way, or because a guest component should be able to load other guest modules, right?
Yeah, so I know where Nathan is heading to, and I think yes, it is possible, because if let me see. So, for example, let's take this one for illustration, right? Let's now say each of those components would rely on a, I don't know, replace capability, right? So they can again import functionality from other components, right? So that from a hierarchy point of view, yes, they would rely on those, but the host application could load those replace components, right? They export the replace function, and then the WASM components over here could facilitate that capability. However, so technically it is dynamic. The sample that I have over here is also dynamic, because we don't compose the application together, right? We will load those components at runtime. So maybe that's where Nathan is heading to with his question.
Yeah, Nathan. So, yeah, I mean, if you can maybe confirm that's where you were headed to with the question, or if there's a particular use case that you're talking about, because, yeah, as I think Thorsten said, in theory it is possible, but
Yeah,
yeah,
I haven't tried it on my own, but
okay,
I think from conceptual point of view, that's how it works, right? Because the world plugin could also import functionality again that the host provides, and so here they are possible with collaboration. Yeah, the TLDR. Yeah, exactly. All right. Other questions, or should we?
No, I think no questions for now.
Okay.
Yeah, folks, if you have any questions, feel free to put them in chat. Yeah, you can go ahead, Thorsten.
Okay, cool.
Let's see some code here.
So, right. So let's digest it by first looking at the transformer. The transformer is like the host application. And if we take a look at cargo.toml, so that is written in Rust, and it has a dependency on wasm time. So that's my runtime of choice. And I'm using the feature component model, which gives me the possibility to use a component model or components instead of raw core WebAssembly modules. The project itself, I will compile it down to my system, operating system / architecture, right? And then we will spawn the WebAssembly runtime inside of that process. Let's have a look at maybe the width first. Again, that's exactly what we saw on the slides. We have the world of extensibility. There's like a namespacing over here. So we define a package name. Then we define the world and we say, hey, I want to use components, or I have an import. I look for things that provide the transform function. So let me quickly scroll to the proper step over here. So what this code basically does is I load plugins from the local disk, right? So there's one folder I call the folder active, where I can just move WebAssembly components into that folder or copy them over there, and then they are taken into consideration. So I start building up a store, then I load the component from the file system, I create an instance of that component, and then I, do some housekeeping, like constructing a list of parameters that I want to pass into the transform function. And because I want to chain multiple component invocations, I track the results, and in the next iteration of the for loop, the result becomes an parameter or an argument that is passed to the component in order to end up with multiple components being invoked. Then there's some safeguarding, so to say. I just double check if the particular WebAssembly component that I loaded from the file system is actually exporting a transform function. So I look for that function. If the function is non-existent, so this is returning an option of a function. If it does not exist, then I say, hey, this component, yes, it is a component. I was able to instantiate it. However, it does not export the transform function that I was looking for. If the function exists, then I invoke the function, provide the parameters, and provide the vector of results, like an array of results, right, as a mutable reference, so that upon invocation, this could be mutated. If everything works as expected, then I just grab the result and pass it over to the next iteration in that for loop. And ultimately, if all plugins were invoked, then I just print out the result from that chain of transformations. So the host implementation, so to say, is leveraging wasm time. And the important thing is also, if we look over there, we have to explicitly enable the component model feature, and we enable WASM component model when creating the config for our WebAssembly engine. All right, so this is the host implementation, fairly simple. And then
okay. Before we move on to one of the guest modules, Thorsten. So
yeah.
I think Rajat has sort of asked one of our resident WASM experts, Rajat, if the message is too big, YouTube basically cuts it out, right? In the sense we can't see the actual reply. So if you can copy paste that again so that we have the reply for Nathan about his question, yeah, or maybe break the message down into two parts, that would be really helpful. But also thanks for reaching out to someone. Folks, Rajat is our colleague, so I think he must have asked on our internal Slack. Yeah, Rajat, thanks for that. Yeah, we have some folks who work in Fermion who also work on like the WASM spec and who contribute to the Bytecode Alliance. So yeah, probably the answer is from one of them.
Awesome.
Thanks, Rajat. Yeah. Yes, Thorsten. So one of the you had just finished the host that was written in Rust, and now we were going to. I know you're not wearing a hat, so I don't know which language.
Yeah, I'm not wearing a hat. Sorry for that. The lighting is not that good in my home office today, so my face looks a little bit red, maybe orange. So let's stick with Rust for now. Yeah. So let's have a look at the uppercase plugin or WebAssembly component. Again, this one is written in Rust. However, instead of creating or scaffolding the project with cargo new, this one for this I use language specific tooling, which is cargo component. And they provide like a new subcommand that you could use to scaffold a new Rust crate, which ultimately has some pre-configured things in Cargo TOML to make it ultimately become a WebAssembly component. And that's what I basically did over here. I said, hey, I will provide a name for the package. That was my old samples, and I don't have actual dependencies, right? Because this component, as we saw again, just have to export a transform capability. We will see an example later in the stream where we have dependencies in place as well. But for this, for the sake of this sample, it's super straightforward, right? Because we don't rely on, let's say, foreign types or foreign interfaces. So we have the plugin world with the export of transform. So depending on your tooling, maybe you have to run a cargo component build, maybe the Rust tooling in your IDE or editor could recognize it quickly, and you end up with bindings RS, which is basically generated language-specific bindings from those WIT files. And in the case of Rust, it is a trait called guest, and the guest trait defines, as you may have guessed already, the function transform that we have to implement. And this is the easy thing, right? Actually implementing string transformation is super easy, no matter which language we will be looking at, because we want to focus on the WebAssembly component things. So we have the bindings module loaded. We bring the guest trait in to context. We define a struct. There are no fields on that struct right now because it's very simple and there's no state that we want to track on the component. So it's just a matter of implementing that particular transform capability. Okay, now let me switch the heads again, and let's have a look at JavaScript. So for JavaScript, we have the combination of Jco and componentized JS. So again, we have the same world over here, right? We have the world plugin export transform, and there was one. I had a conversation after my talk in Barcelona about that. Yes, I could have easily moved the WIT to the plugins folder and load it from there. However, to make it like more self-contained, I decided to copy the WIT files into every plugin implementation. So yes, there's room for improvement, and maybe someone takes that opportunity and submits a PR. That would be great. So you don't have to copy that thing around. If you're in charge of the entire source code, you can easily place it somewhere in the root directory and link it from there. That's definitely possible. All right, so in JavaScript, we also define the export function. However, it's even easier because at that point in time, there's no tooling involved yet. We have to export the capabilities that are defined in our WIT world, and in our case, again, that is the transform function. So here we check if the import is truthy. So if it is falsy, we just return whatever we received, assuming that could be an empty string, that could be nil or null, or undefined, and whatever becomes false in JavaScript. If it is truthy, then we just reverse the string by splitting it, reversing the array, and joining it again together. All right. Let's have a look at what happens on the language-specific level right now. So there is the make file in the extensibility sample. And if we look at the uppercase, remember this was the Rust, the plugin implemented in Rust. So we move into the directory over here, and we use language-specific tooling, speaking of cargo component, to build for our desired platform. I use WASM32 unknown over here to remove like certain exports that are there by default. Because if you compile down to WASM32 WASI, it will ask for several WASI interfaces, WASI types, and you could get rid of those by compiling down to WASM32 unknown. I move them after building the components. I move all of them to a central place, like over here. You see in the root folder, to smoothen the demo that we will see in a second. For reverse, it's the same. I move into directory. I use language specific jcom componentize JS. Point to my source file, point to my wid file, and expect the output to be called reverse.wasm in our case. Then there's a language agnostic tooling like wasm tools. They have a strip command that you can use to shrinken the JavaScript based WebAssembly module a bit. So this is language, all language specific and language agnostic tooling that we use. Besides that, if you have a look at the repo, there are some like helper targets in that make file that you can use to easily get things up and running on your machine. And that's what we want to do right now. So let's move to the terminal. I'm in the extensibility folder over here, so I can do a make run, make start, make run, and I can do a hello live stream. Oh, and I missed the E, but basically you can see, let's do it again. Hello live stream. Okay. And basically
proves that we're really live, Thorsten.
Yeah.
We're actually live,
yeah. So no transformers found. And as you can see, the host keeps on asking the user in an endless loop for inputs and tries to apply transformers that are located in the active folder. So there are no there. So if we do a ls in active, we see nothing's there, right? So we can do a make build all plugins, and this invokes all the make targets to build those plugins that are in the repository. So it takes a couple of seconds, and finally we end up with 3 WASM files. So we have reverse.wasm, we will have uppercase.wasm and obfuscate.wasm. Right? So they are located over here. And as you can see, 7044, 7044, 7044. So we can now start moving those into the active folder. So let's take the reverse and move that one to active. And we can do a hello live stream again. Now it takes a little bit longer, and you see it reverses the string. And now let's take the uppercase and move that one as well into active. And let's do a hello live stream again. And we should get back everything uppercased. The obfuscate, we haven't looked at the actual implementation, but maybe you can expect what I'm doing there. So let's go ahead and take the obfuscate and move that to active as well. And let's go with hello live stream again.
Nice.
So it's just a simple, replacing several characters from the input with stars to obfuscate something, right?
Nice.
Yeah.
And if you remove, sorry, Thorsten, if you remove one of the .wasm files, right? Like say if you remove the reverse one from the active folder.
Yeah. Let's remove that. Okay. So now we are back to obfuscate and uppercase.
Yeah.
Hello live stream.
Nice.
Now it's just uppercasing and obfuscating.
Awesome.
I think I implemented some sort method on the iterator of paths. Basically, I'm just asking, hey, which files with the .wasm extension are in that active folder? And then I think there is a like sorted by ABC, I think by file name ascending something. Does that make sense? Maybe.
Okay.
Yeah.
Okay.
Yeah. Obviously, yeah. If you come up with a more sophisticated world of extensibility, you could think of having an order, maybe a title that I could
Of
easily
course.
print. Okay, now I'm applying the uppercase transformation, then I'm applying XYZ. Yeah.
Yeah.
So this one was the something that immediately came into my mind when I stumbled upon the component model is the possibility to roll my own extensibility story. Although there are way more sophisticated frameworks available to do extensibility, this one allows me to define particular points where I want that extensibility, and I don't have to, build SDKs for a whole lot of different languages and whatnot. I can simply say, hey, this is the WIT world. These are the contracts you have to fulfill. And then you could become a plugin for my super fancy transformer application over here.
Yeah.
All right.
Awesome. I'm going to quickly just do two things. So one is just quick recap of what we are doing. Thorsten here showing us like a real life use case of a component world example. The component world is something that the Bytecode Alliance, and of course it's built into Spin, etc., went live late last year, I think. So it's not something that is there in real world use cases so far, but now we're slowly seeing, like use cases and people sort of building with it, and that's what Thorsten's showing us. The second thing is there was a question asked by Nathan earlier in the stream, which was a very interesting question, which was, is it possible for a WASM guest component to dynamically load and link to multiple child guest modules? So we sort of discussed it, and Rajat, one of our colleagues who's watching the live stream, was kind enough to put this on our internal Slack, and we got the answer from another colleague, Ryan, who who also has a great talk at WASMI about the component model, which says that there needs to be some sort of collaboration with the host for that to be possible, and he's working on on a project that allows you to do this. So if you go to github.com/rylev, which is Ryan's GitHub /Dyna, it exactly allows you to do that, right? For a WASM guest component to dynamically load from multiple child guest modules. So if that's something that you're interested in, go to Ryan's GitHub and yeah, check it out. Oh, we can just go to it right now, maybe. Yeah. Oh,
What's
I think it's,
Dyna?
yeah, RYLEV. I think you have an extra L. Yeah.
Oh, sorry. Yeah.
All right. Yeah, there we go.
There we go. Okay. And once you're here, you can go to Ryan's profile and you can have a look at
Yes.
WebAssembly.
REPL awesome.
Yeah, WebAssembly is also a great tool if you want to inspect what's going on with a WebAssembly component. So, for example, the good thing is we have several components over here, the uppercase, the reverse, and the obfuscate. So I have WebAssembly installed over here, and I can simply say, hey, go to the WebAssembly uppercase.wasm. And what WebAssembly allows you to do is basically, let me maybe rearrange that a little bit. So you can print the imports, the exports, and so on and so forth. So for example, let's say exports over here, and you see this component exports a transform function that takes a string and returns a string. And if we take a look at the imports, we see nothing because we don't have any dependency, right? And I guess, adding on Nathan's question, that if you have an import over here, you have through the host to fulfill, you can fulfill that import again. Yeah. So also check out WebAssembly, great stuff. Cool. So this was a sample to, set the stage a little bit for the component model, but there's a even more realistic sample that I created. Come on. So, all right, you should see my slides again, right?
Yes, we can see it.
Yeah, okay. So consider the following scenario. We have a product that's called Acme, and Acme is like an they have like an HTTP API, and they allow third parties to register the intent for webhooks. So every time when something of interest happens inside of Acme, they send out an HTTP post to whatever URL you provided upon registration, so that in this case, for example, Wonka is a third party that uses Python to code their stuff, right? And they are interested for particular events happening in Acme. And if that event happens, Acme sends an HTTP post over HTTPS to Wonka, and they can take it from there, work with the payload, maybe call back into Acme to retrieve more information about the thing that happened. So wouldn't it be cool, or maybe the product management at Acme at some point decided, hey, we want to be a good webhook citizen or webhook provider, right? We want to sign payloads that we send to our customers, so to the webhook consumers. This involves, that upon registration, Acme creates or computes some random key material, because we want to sign messages for Wonka in that case with a Wonka specific key material. And when there's I think there's another sample in the repo called Cyberdyne, if they receive a webhook, their specific key material is used to verify the integrity of the payload. But again, following the same step as in the extensibility sample, how would that contract look like in WIT? So Acme, the developers at Acme have to sign arbitrary payloads or bytes, right, using key material, and expect like a signature, or it's often also called a tag, as a result, which is also a list of U8, could also be a string. But I went with U8 in that case. On the flip side, the consumer of a webhook, so me right now working at Wonka, right, I want to ensure that everything I receive over HTTPS from Acme is or has not been modified during transit. So I want to verify whatever I receive using the key material, my Wonka specific key material. And to me, it's okay if I get a Boolean, yes, it's valid, or no, there has been some sort of modification to the payload during transit. And what the WebAssembly component model allows us to do with that is we can define a new world called HMAC, because HMAC is like a standard algorithm that we can use to sign and verify signatures. So we can define the HMAC world and provide two functions, or two interfaces. One is a signing interface, and the other one is a verification interface. And again, the signing interface exports a sign method that is used by Acme, and the verify function that is exported by the verification interface could be used by every consumer, no matter in which language they use, as long as they can work with WebAssembly components. And this allows us to solve the problem once and hand out like the world of verification. So what we see over here with Wonka, as an example, right? Then we can hand out the world of HMAC together with the .wasm file. So we can step up and say, hey, dear consumer or customer, right? You want to use our webhook system? Great. Hey, by the way, we sign all our payloads, and here is the contract that you have to, or that you can use in order to verify all the payloads you receive. And by the way, you don't have to implement it on your own. We did that. There is the implementation, right? There is the .wasm file. You can just throw that into your build pipeline, so to say, or and compose your application using our WebAssembly component. And that's what we want to look at right now. So let's move again to the
Yeah.
terminal.
On a
Yeah.
side note, I think this is it's such a cool use case because it's such a real world problem or real world use case, right? And it's so important, I think, given that more and more things are moving into tech, to have this sort of verification on both ends. So I think it's something that hopefully the component model sort of unlocks. Dean, you had a very similar question, which is there a way to lock down access to my endpoint with the security token yet? I think something in the component model was needed for this, right? Dean, I hope you're still watching. I know you asked us this at the start of the stream.
Ah.
Yeah, but I think this is this is exactly what you were talking about.
All right. So, and this was basically also part of the Was My O talk where I started moving the heads, right? So we started with Acme. Acme decided to use Spin to craft their API. So this is a Spin application written in Rust. And as you can see, there are some, for the sake of demonstration, there's outbound connectivity allowed to localhost 3001. That's where we will run Wonka at some point in time. And 3002, that's where the second consumer could live, like Cyberdyne that lives on 3002. All right, so let's have a look at this sample. So it is an HTTP API, so that provides some endpoints. So third parties can send a post request to registrations to register and say, hey, I'm interested in receiving webhooks for, let's say, customer has been created, or whatever the event is, right, that I'm interested in. For demonstration purpose, there's a dump or delete registrations. And that dump is for printing all the registrations. And again, for demonstration purpose, there's delete all registrations so that you can easily clean the surface when playing around locally. And there's obviously an endpoint for simulating the act of something happening in the system to fire a webhook. Let's have a look at registration quickly. Where is the dump registration? Register webhook. So the interesting thing is signing key. Where is signing key defined? Register webhook. Registration new, yeah, that's what I was looking for. And there is a generic key. So for every registration, there is a unique key that is being created, right? So that we can have consumer specific signatures so that if Wonka accidentally, hopefully it will never happen, receives a payload that was intended to go to Cyberdyne, it will treat it as invalid because Wonka doesn't have the random key material to verify the integrity of that message. But technically, I mean, the registration is very, very unspectacular. It's just taking the URL that the customer provided, the events the system is interested in, and that random key material, and dumps that or stores that into a database. So, and the interesting thing is the demonstrate firing. So I load every webhook consumer from the database, generate a registration type again, and then I start iterating over all consumers. Then I create some payload that would be the same, that could be removed one line up. But what happens then is I call into the sign method to compute the signature for that and send a HTTP request to that particular webhook consumer, sending the signature as an HTTP header and the payload that is intended to be sent there. Whenever then we just use outbound HTTP to send the request and just dump the response to the terminal. So the question is, how can we get access to sign, right? So in our spin application, I have a world.wit file over here. As you can see, we define the world of signing, and I'm importing a capability from an external dependency that's called Fermion HMAC sign in version 0.1.0. And if we go to our language specific configuration, this is the difference to the hello world example we looked at right before, right? So we have the package specification, but we also say, hey, I rely on other WIT files. And by the way, you can find them in one level above, HMAC, there's a WIT folder, right? So let's collapse this one. Let's have a look at HMAC. In the WIT, we have the WIT world of signing. That's the one that is imported, but we are only importing the sign interface. And this gives us access to the sign function that takes in arbitrary data, random key material, and returns technically it returns a result that could be okay, so everything works well. We could compute a signature, or we ran into an error, and then in that case we retrieve an error, right? But if hopefully things go well, then we end up with the signature. Okay, the implementation, and this is pretty much the same as in the uppercase plugin we looked at a couple of minutes ago, right? So at some point, we end up with bindings for that particular WIT world over here. So for both signing and verifying. I then decided to have a look at the Rust ecosystem, right? So I just went to crates.io and tried to look, hey, has somebody already implemented HMAC? And yes, there is the ring crate that implemented the HMAC algorithm. So I could easily implement both traits because there's a sign guest trait and there's a verify guest trait. So this is, I decided to have dedicated interfaces to make this code reusable, not just among different languages used by webhook consumers, so that also the webhook producer could reuse the same code and no one has to deal with, let's look in the documentation, which algorithm and which key size and blah, blah, blah. So those discussions are like gone, right? That's why the signature is a little bit more complicated as it could be. Okay, so then it's me just using the ring crate to implement the signing capability and to implement the verification capability.
Nice. Yeah, folks,
right.
I think we have just enough time for like maybe a question or two. Thorsten, I actually have one question,
Yes.
which is, and this is very general, which is, where do you see usage of the component model first getting into mainstream, right? Like if you talk about actual people in production,
Yeah.
enterprise, startups, whatever, where is the first place you think, people will start using component model type things?
It's exactly what we are looking at right now. It's
Yeah.
getting rid of technical of infrastructure code, how I often refer to it, right? If I think like I'm an application developer, I have to solve that business requirement, right? I don't want to care about which algorithm do I have to use to verify the integrity of a message. I want to okay, I have to call verify and I get back a Boolean and then that indicates, hey, you're good. No, maybe you're facing man in the middle attack. Maybe something's weird over there. This is exactly where I think the component model could become very popular especially for larger enterprises, right? Because this is just one example, and maybe transparent caching, maybe, I don't know, authentication, whatnot, right? There are so many technical requirements that we have to solve these days. And by using the WebAssembly component model, we can solve them once and reuse them, no matter which language. We don't have to stick with that language that someone decided like 20 years ago.
Yeah.
That as long as we can compile it down to WebAssembly, then we can use the component model to,
Mhm.
make it more general, accessible. Yeah. So I think
Yeah.
technical components
Yeah,
still the same.
I'm in full agreement, right? And I think, again, if you're following the news, also you're probably seeing some stuff about similar sort of like man in the middle supply chain attacks, and I think this is it seems like it's just designed to solve a problem like that, like this just verifying. And as a software developer, I don't have to really like break my head into looking at like standards and security stuff when I can just implement something that's absolutely working. Bunny also says there's pushback against microservices models, like the Netflix server architecture was Amazon Prime's microservice model. So I know maybe component model also enables some replacement of this whole microservices type thing, especially for extremely large workloads like like an Amazon Prime type thing.
Yeah.
And I fully realize the irony of wearing an Alexa t-shirt while saying that. Yeah,
Yeah.
yeah, because WASM does allow some sort of microservice benefits, right? In the sense that it's different. I don't want to say components, but it's very abstracted. They're all in multi-language. They're all talking to each other. But the
Yeah.
side effects of hosting these elements across different functions, there you hit the nail on the head, Bunny. Kay also asks the question that is on everyone's mind, which is, but is the component model production ready? I say yes from what I've heard and read about the component model. I think it's at a stable release. It's yeah, but I don't know. What do you think, Austin?
Yeah, I think it's definitely usable. I mean, you obviously, the tooling space is still evolving, right? There are still things happening over there. I had like that one slide about WAC, the WebAssembly composition, that may find its way into WASM tools again, which may, will end up me as that I as developer, I have to maybe realign what happens in CI, how do my scripts look like. But overall, the component specification, the WebAssembly component specification is definitely something you could use to build things like that, right? To extend or to address common needs maybe across your spin applications once,
Mhm.
and stop repeating yourself over and over again, maybe different languages, right? So that's,
Yeah.
I think, we are at a good point where we can start using the component model for real world scenarios. Yes.
Yeah, I agree. So here's my take, right? Is the component model production ready? I say yes. Is it in a state of evolution? Also yes. I think the two, yeah, I think the two things that we will see a lot of improvements on is one, the developer experience around it,
Yes.
which once it gets better, I think more people can use it and more people can implement it in like their day-to-day and real-world use cases. And the second, I think, is more of a more very popular registry.
Mm.
During WASM IO, I know how you refer to it. Is it called the WebAssembly Component Registry? WA.dev basically was launched.
WA.dev.
Yeah, WA.dev. I put the link up here.
Yeah.
And that was launched as the WebAssembly Component Registry. So, once I
Yeah.
think that becomes more well used or more people use it, we will have like this official registry where there are components for all the things that we want to do, like the example maybe Thorsten gave, which also Bunny saying that they did some work like this in the past, but there was no benefit of WASM, right? So 15 years ago, to just do something like this, it was super hard to do. I'm sure there was
Yeah.
like an entire like engineering team looking to solve this problem for very, very secure workloads. So WASM sort of enables just doing that. Yeah.
Yeah. I think W.A.dev addresses one of the one of the shortcomings that we have, that is discoverability, right?
Mhm.
How can one find out what's already out there? Do I trust that vendor? Yes. Okay. Then I can grab that component from a central place, grab the WIT file, and start from there instead of starting from scratch.
Yep,
So
absolutely.
that's definitely valuable to have
Yeah.
a W8 dev in. I think it's public beta, right? Yeah.
Yes, check
Yeah.
it out.
Okay.
And you have a comment from ancient IT guy who was on our stream last week. Thank you, Austin, for that impressive feat of German sample engineering. Learned a lot, which I also learned a lot. Very cool, Thorsten. Thanks, guy, for watching. Anything else you're demoing, Thorsten, or should we call it a day for this stream?
Just give me 2 minutes. 2 minutes. Now
Okay,
3 minutes.
yes, 3 minutes. Yeah, 3 minutes.
So
Okay.
let's quickly have a look at Wonka, because Wonka is a spin app as well. This is written in Python. And again, this has a world of wit. And this is the tooling part. Maybe we both talked about it like a minute ago, right? In Python with componentized Py, dependencies are not, I can't reference them from by using relative paths. I have to provide dependencies in a depths folder over here. So there, yeah, it could be unified by again pushing the world down there and refactoring my way of organizing things. But the intention was to make it demo friendly. So this time, the consumer, Wonka, they are interested in verifying, so they import the verify interface from HMAC. Again, HMAC has the export interface verify, which again exports the verify function. In Python, there is nothing special, right? It's the same as in Rust, but we Python language specific things, like I have to bring in the verify capability over here. And at some point, what do? I load the consumer specific key data from the Wonka specific store. So at Wonka, they decided to use, I think, key value, if I remember correctly. Yeah, to store their key data. Then they take the request body, and a tag is what they grabbed from the request header, right? The X signature header. So they use those three pieces to call into the verify method, which gives back a Boolean indicating if the language has been modified in transit, which is that, or hasn't. So connecting the dots, again, there's one top level make file that calls into smaller make files for, again, demonstration purposes. So if we look at a Python example, we ensure that we are in the right virtual environment for Python. Then we install all our requirements, and we use componentized Py to create the component from our app. So now that we have the app component, we must compose the final application by taking the HMAC component and composing it together with the application component, right? And this is done by language agnostic tooling, speaking of WASM tools compose, where I can say, hey, I have the dependency that's called hmac.wasm, and I have an app, my spin app.wasm, and I please go ahead, compose both, and create a compose.wasm. The same happens in Acme, only with Rust specific things. I use cargo component build to build my app. So I end up with the app. The imports are not yet fulfilled. Then I use language agnostic tooling, WASM tools compose, to fulfill the import of our app component by taking again the hmac.wasm component, pointing it to my acme.wasm, and say, hey, please go ahead and also create a composed.wasm for the acme. So last minute, let's go ahead and let's say make start Acme. Let's go there. Let's say make start Wonka. So Acme is running on 3000, Wonka is on 3002. So we can make register Wonka, which calls into 3000, right? And says, hey, please register Wonka at 3002, and then a signing key is created. You see the logs over here, received 3Z8 upon registration for webhooks with Acme product. Store signing key in key value. So this is Wonka specific in the lower terminal, right? Okay, so now that we are registered, we can simulate something interesting happening in Acme. So what happened over here? We see the so we invoked 3000 fire, right? This one goes to Acme. Acme iterates over all the consumers and calls down to 3002. And then we see, okay, we received a tag over here. That's the HTTP header. That's the first piece of the puzzle. Then we load our custom key data from our store, right? That's again 3Z8, whatever. And then we can verify the integrity of the payload that we receive from Acme, resulting in a truthy check, so meaning that the data has not been modified in transit, which makes us return an HTTP 200, which again is logged over here via Acme. So we can roll like a full-fledged signed webhook system using the WebAssembly Component Model to, push away that technical implementation of signing and verifying actual payloads. Yeah.
Nice. That was 4 minutes, Thorsten, but we'll allow it.
Yeah, sorry.
Nah, yeah, I'm joking, of course, but yeah,
No,
that
I
was.
think.
Go ahead.
Sorry. Go ahead. I just want to close down with. I think it is worth at least pointing all of you to the right, like make files and whatnot, so that you can take it from there. Yes, thanks. So on the repo is public. Give it a try. Just clone it, play around with it, and let's reach out if you have ideas, problems.
Yeah, feel free to reach out to either Thorsten or myself. The entire repository is here for folks who just joined, like Kay. Come watch this video later. Thorsten goes through everything step by step. And there's going to be a lot more that we will be demoing about things like the component model and the usability and more real world use cases as well. We're almost at the end of time. I think we went a little over today, but thanks folks for joining in as usual, like Bunny and Kai and a lot more people. Kay, I see Nathan and Rajat and Dean and so on. So thanks again. Next week we're doing something cool. So during KubeCon 2 weeks ago, we actually put SpinCube on a SpinCube, which is on a Pico cluster, like a Raspberry Pi cluster. And Radu essentially built that out. So he's going to show us how he actually did that. So he has like SpinCube running on a Raspberry Pi cluster. So it's going to be fun. I don't know if the cluster will also be on stream. Maybe it will. It looks hella cool. So let's see how we can get that also on stream. But that's what we're going to do next week. So I hope to see you all there. Until then, from Thorsten and myself, thanks for watching, and we'll see you soon. Bye-bye.
Bye-bye.